How are we doing today? We'll see if anyone shows up. So for those of you that are actually on, or those of you watching on YouTube, we have a dual credit lecture today. I didn't get any email questions yesterday, so I'm assuming pre-cal, your assignment went okay. I mean, a good few of you turned it in. I'm not sure exactly how much work got done, but we'll see. Your tests should be graded today. I should almost be done. Let's see. Yeah, I'm not getting many questions this week. So either something going really well or something's going really poorly. And we'll figure out what's going on in a week or two. Remember, this week, for dual credit, this isn't gonna matter much, but this week is the end of the 6 weeks. So especially for your other classes that are high school only, be sure you're keeping up with your work. I know that it's a little bit weird with the online school part, but yeah, all our teachers, all of us were finalizing grades this Friday, April 3rd. I have no idea what time grades are due, but if the rest of the other 6 weeks have been holding up, it's going to be Friday at 10 p.m., although they probably will change it this time around. We'll see how it goes. Okay, so I think we're just going to jump straight into the lecture today, because I got 0 emails yesterday. So dual credit, we're going to be doing 6.2. Remember, Chapter 6 is the last chapter of our textbook. It is a pretty short test, but at the same time, you need to be sure you... it's still going to be quote-unquote 10 questions, even though it's only going to be numbered up to 6. And I'll talk about that more when we're actually done with the lectures. Again, I'm just safely assuming this is going to go on through the end of the school year, especially with the shutdown officially going on through April 30th. I don't think we're coming back for just a week or two. I mean, at this rate, there's a good chance it'll affect the beginning of school next year too. So we will see how it... I mean, nobody knows what's going to happen. So, all right. I'm just going to pull up this presentation. And if anyone ends up with any questions in chat, just let me know. It can be about the homework, it can be about the lecture, whatever you need help with. So the second section of Chapter 6 is the Law of Sines. Section 1, we just got done talking about right triangles, right triangle trigonometry, SOHCAHTOA, using sine, cosine, tangent, cosecant, secant, cotangent with triangles now. So the law of sines is the next extension of that, because everything in section 1 was a right triangle. But that's not going to happen all the time in geometry or in word problems or in real life applications. So the law of sines is one way of extending the ideas that we learned in section 1 to just general scalene triangles, or we call them oblique triangles. Triangles that don't have specific symmetry, or have to have a right angle or anything like that. You can use the law of sines with any triangle that exists, as long as it's actually a triangle. So here it is. It's I mean, you're not going to have a formula chart for exam 3 if we are taking exam 3, but just have this starred in your notes. It'll be a formula that you use a lot in this section, and of course on the exam, because you're going to have 1 or 2 questions from every section this time. Remember, just for notation purposes, lowercase letters, the ones on top of the fractions, are sides, and capital letters are angles. Technically, you don't have to put the sides on top and angles on bottom. You'll have other textbooks that have sine A and sine B and sine B on top. With fractions, if they're all equal to each other and there's no adding or subtracting, you're allowed to, flip them upside down if you want. For example, if I do something like this, let's come up with other letters that aren't C over D, something like that. So if you just take a look at a pair of these fractions, this is the scenario that you have. If you just cross multiply and divide, the fact that multiplication is commutative, that you can do it in either order that you want. If I do the cross multiplying part of this, and here I can divide the x over and divide the c over. So what ends up happening is you have the exact same equation with the fractions flipped upside down. So you're allowed to flip both fractions upside down. I just realized I wrote underneath my overlay again. I really need to get used to this. There you go. So you see it right there. Anyways, here's the law of sines. You'll use it a bunch. So let's do a problem. In the triangle ABC, now remember, C isn't defined to be a right angle anymore because we don't have right angles anymore. So letters A, B, and C can be in any order you want. So you've got B equals 4 centimeters, angle B is 40 degrees, and angle C is 75 degrees. Find lowercase c, so find side C to the nearest tenth. The most important way to start the law of sines is figure out what pair of letters that you have. The whole conceptual idea behind the law of sines is that you have a triangle, so you've got 3 sides and you have 3 angles. Every side has an opposite angle associated with it. If you look at the fractions are proportions, right? So if you look at b and sine b, for instance, you divide that and you get a proportion, you get a ratio, and that ratio / proportion should be equal throughout the entire triangle. So however big side b is should tell you roughly how big angle b is, and that ratio should be the same for side A and angle A, for side C and angle C. And it's not directly to them, it's to the sine of the angle, but the idea is still there. Bigger side equals bigger angle, smaller side equals smaller angle. Okay. So here we have side B and angle B. So one of the fractions, we're not going to use all 3 of these simultaneously, we're just going to pick the 2 that we need. So I'm going to use b over sine b equals, now I want side C and I have angle C, so the other fraction that I'm going to use is c over sine of angle C, which is 75. So notice how by using those 2 fractions we've created an equation that only has one variable. Little c is the only variable in the problem. So we just need to solve for it. And here the only thing you have to do is c divided by sine 75, so multiply it over to the other side. Okay. So that's canceled. So all I have to do to type in my calculator, make sure you're in degree mode, is 4 over sine 40 times sine 75 in whichever order you want. So let's open up the old calculator. Alright, make sure we're in degree mode. We are. And we want to do sine of 75 times 4 divided by sine of 40. And be sure to close all your parentheses properly. So it says round to the nearest tenth, so 6.0. If you try to do a quick sanity check on this, it makes sense. B has a side of 4 and an angle of 40, so it makes sense if angle C is a little bigger, side C should be a little bigger. So in the scope of what we're talking about here, seems okay. So C is 6.0. Make that point a little bigger. Okay. So this is going to end up being one part of the problem, because if you remember, by the end of 6.1, what you needed to do was solve the entire triangle, right? So, you know, all triangles have 3 sides and 3 angles. This is finding you one missing piece. We got to figure out how to do the rest. So let's talk about the next part of this. Now you have a triangle. Side A is 10, side C is 20, and angle C is 60. Now you want to find angle A. So, hey, good morning. Okay, so we have C and C, so we have side C and angle C. So we know one of our fractions is going to be C over angle C, so 20 over sine 60. Now, we want angle A, so we need side A to do that. So luckily they have that in this problem. So my other fraction is going to be 10 divided by sine of A. And now the unknown thing is the angle, which does add a couple of steps of work. So there's two things different, or wrong with this scenario. One is that the variable, the capital A, is in the bottom of the fraction, so I can't just get rid of the 10 and call it a day. I've got to move it out of the denominator. The other thing is it's inside of a sine function, so I've got to use an inverse sine like we learned back in chapter 4. We need to get rid of the sine with an inverse sine, so we've got to isolate it first, solve for it. So like your old school teachers taught you back in the day, we can just cross multiply and divide this. So we've got 20 sine A equals 10 sine 60. Now remember, the goal is to get A by itself, so next I'm going to divide the 20. So let me write this over off to the side, hopefully not under my webcam. You've got sine of A equals 10 sine of 60 over 20. So that's what sine A is, but we want to know what angle A is. We have to get rid of the sine part of the problem. So to cancel sine, we use inverse sine. We don't have to worry about any domain things because we're talking about triangles. We're never going to have a negative angle. So I just need to type in inverse sine of that fraction and I get my answer. So let's head to my calculator. Inverse sine, make a little fraction thing if you want, 10 times sine of 60 divided by 20, and we get 25.7 degrees. And again, it makes sense angle A is smaller than angle C because the side is smaller. And it's not a direct proportion. Just because you cut the side in half doesn't mean you cut the angle in half. So you see why it's a little bit trickier than just doing a direct proportion. So A is 25.7 degrees. It's really hard to make little dots here. Okay. Okay, this is usually going to be the part that bothers people the most on the exam. I mean, on your homeworks too, because you're going to need the practice. I put all the official terminology on here, but let me give you kind of the abridged version, or the ambiguous case for dummies version. Not that I'm not saying that you're a dummy or anything. I'm just going to stop. Okay. I'm not funny this morning, I'm sorry. Okay, so the ambiguous case is anytime you do this inverse sine thing, there is a chance that this angle is not the only angle, or this angle is the wrong angle. The reason that happens is if you think way back to chapter 4, inverse sine is something we're using, right? But it can only give you answers in quadrants 1 and 4. Now, we don't care about angle or quadrant 4 because we never have negative angles, but what we care about is inverse sine can only pop out angles between 0 and 90. But triangles can have angles bigger than 90 degrees, right? So if you set up law of sines, if you do, A over sine A equals B over sine B, whatever, and the other angle is supposed to be a really big obtuse angle, like 130 degrees, your calculator will never tell you that, because inverse sine, by definition on your calculator, by whoever is way smarter than us and decided this, is only going to show you answers up to 90. So we have to manually assume that the stuff over in quadrant 2 could be a possibility, and we have to check it every single time. So that's what we call the ambiguous case. anytime in your calculator, anytime you type in inverse sine, your calculator will spit out an answer, but you also have to figure out the supplement. So 180 minus whatever your calculator says. There is a possibility that case, that is another possible answer for the angle. Now, sometimes the ambiguous case, the second angle you make, it's gibberish and it doesn't mean anything, but sometimes it does. Sometimes your problem doesn't even work at all because you'll get a no solution out of your calculator. So ambiguous case means that anytime you use inverse sine, you could have 0 triangles, you could have 1 triangle, you could have 2 triangles. All of them are possibilities. So the one question I'll preemptively answer before I move on is, wait a minute, how do you get 2 triangles? Well, remember, all of these problems start off with giving you 3 pieces of information, right? Where they give you, either 2 angles and a side or 2 sides and an angle. So in the case where you specifically have 2 sides and an angle, let's say I have a triangle and I tell you how long this side is, and I tell you how long this side is. Let's see. And then I tell you what that angle measure is. So those are your 3 pieces of information. Sorry, I made that way too long. Let me rewrite that. So, I didn't make that any better, whatever. Okay, so you don't know, here, let me use a different color. So you don't know how big that angle is, you don't know how big this angle is, and you don't know how long that side is. So you could do your math, you can set up your law of sines, you can, cross multiply, divide all you want, and your calculator might give you this angle as like 30 degrees or something. So let's pretend you have 30 degrees. There is a chance it's also 150 degrees. There's a chance, just look at the red ones. If I keep that the same and I keep this the same with however long this side is, there's a chance this, using the same length, you just swing it over to the other side and you're still following the same given measures that the problem told you, but this angle is way different, this angle is way bigger, and this side is way different. Both of those triangles are technically possible with the red pieces of the given information. So that's why ambiguous case exists. Sometimes you have 2 triangles. And I'm not expecting everyone to get that right away, but the best way to really visualize it is try to draw pictures of every answer that you make. You don't have to do that. I'm not going to do that for the rest of the examples, but if you're confused as to why 2 triangles, 2 sets of answers could exist, this is why. Okay, so now let's get into the problems that you're going to see on the exam, because these are going to be what they look like. Solve triangle ABC, angle B32, B is 100 feet, C is 150 feet, and of course round everything to the nearest tenth. So all of the law of sines problems start off with what pair of information do you have? So I have B and B, so 100 over sine 32 is equal to 150 over sine C. Because remember, side C should give you angle C. Okay, so this is another case like we had back here where we want to solve for an angle, so we're going to cross multiply and divide. The difference here is that once I find that, I'm not going to be done with the problem yet. So cross multiply, I have 100 sine C equals 150 sine 32. And then to save a little bit of space and time, I'm just going to do both things here. I'm going to divide 100, and then I'm going to inverse sine right now. So for angle C, I need to do inverse sine. Here, let me move my calculator over. Okay, so I need to do inverse sine of 150 sine 32 divided by 100. And I get 52.6 degrees. See you later, Caleb. Oh man, those of you still going to work, I applaud you. That's nuts. Okay, so C. So my calculator says angle C could be 52.6 degrees. Now here's how you apply ambiguous case. So my calculator says 52.6 degrees. But remember, I don't know what the rest of the triangle looks like. There is a possibility that the supplement of this angle, so in case here I'll call this case number 1. There's a chance case number 2 where C is 180 minus this, so 127.4. There's a chance that that is also a possibility for angle C. Here, let me move my webcam around a little bit for this one. Let me shrink myself a little bit. There we go. Fit myself in right here. Hold on, doing a little bit of a... Hey, there you go. Okay, so now I'm not worried about writing underneath my own face anymore. Okay, so there is a chance that both of these are possibilities for angle C. Anytime you type inverse sine in your calculator, you've got to check both of these scenarios, which is going to be annoying, but you won't have to do it the entire test, but anytime you do law of sines, you will. So let's just talk about case 1 right now. So remember, they already told me in the problem angle B is 32. I can't change that. There's nothing I can do about that. But in the case where C is 52.6, I need to finish solving the rest of the triangle. So I need side A and I need angle A. Remember how even though we don't have right triangles anymore, all 3 angles have to add to 180 degrees. So if C is 52.6, A has to be whatever is left over out of 180 degrees. If you have 32, oh sorry, I didn't write the 180. So 180 minus 32 minus 52.6. Because the 3 angles have to add to 180 degrees. So you've got a sum of 84.6 there, so this is 95.4. And now that I have angle A, I can do law of sines to find side A, which is a little quicker because you've got A over sine A. And then now I actually have C and C and B and B. I have both pairs. So you can use either one you want. You'll get an identical answer if you did it correctly. For me, I like to be safe and use the pair that the problem gave me because I know I didn't screw that up. There's a chance I screwed up C and C. So I don't want a wrong answer to give me another wrong answer. So I will use B and B because I know those numbers are right. So solve for little a, multiply the sine 95.4 over. And little a is going to be equal to whatever my calculator says. So, okay. So 100 divided by sine 32 times sine 95.4, 187.9. And again, it makes a little sense. A is the biggest angle. It should get the biggest side. So 187.9. So that's one possibility for what the ambiguous case is. Now I've got to hop over to case 2 and check this as well. There's a chance angle C is 127.4. I already know B is 32, so over in this possible scenario, when A is the leftover, okay, So in case 2, ambiguous case number 2, the two angles that I know add to a sum of 159.4. So I've got 20.6 left over. So now I'm going to do the same work. The steps of the math are going to be the same, except angle A and angle C are different. So I've got A over sine of 20.6 equals, and again, I can do B over B or C over C, same thing. I'm going to do what I did before. So solve for A by multiplying the sine of 20.6 over. And I'm running out of room a little bit, but notice how I'm typing in the exact same thing, except instead of 95.4, I'm typing in 20.6. And I get 66.4. And now angle A is actually the smallest angle I have, so it makes sense that it's the smallest side that I have. Oh, that's not great. Writing is hard. There we go. So that is the ambiguous case. Now, not every single problem in this section is going to be this long. This is an example of the longest any of these problems would ever be. Just because you've got ambiguous case and both of them actually happen to give you things that happen. I have two more examples here of when ambiguous case doesn't matter. Okay? So don't get too discouraged. Not every problem is going to look like this. Okay, same example, same instructions. So solve the whole triangle. Here's angle A, side A, and side B. So first thing I can find is angle B, right? Makes sense. So I've got 8 over sine of 50 equals 15 over sine of B. So cross multiply and divide like we did before. We get 8 sine B equals 15 sine 50. So my two things to solve for angle B is to divide the 8 over and then inverse sine that. So I'm going to inverse sine, come on, 15 times sine of 50 divided by 8. And what do you know? It all got typed in right, but there's an error in the domain. Remember, if you think back to chapter 4, you can only plug in numbers between -1 and 1 because of the unit circle. So that means this does not fit within the domain of inverse sine. Oh, sorry, Julie, I just saw this question in chat. How do you know which one is actually A? They're both possibilities for A. So back here. So because of the ambiguous case where C could be 52.6 or 127.4, however big, B is fixed. I can't change B. So however big angle C is going to determine how big A is. So in case number 1, you could draw a picture of it with, side B, angle B, and then, little c, if you look at this little sketch here. So if you just pretend this little part is C. So there's a chance C could be kind of big or really big, right? So here, if C is this big, that's going to make A be, that big. If the ambiguous case works and C is way bigger, that's going to force A to become way smaller, just to still be an actual triangle. So when you have a problem that says solve this and here's your given information, both number 1 and number 2 are possibilities for what the answer. Yes, both are your final answers. You would need to box all of them. And you need to organize your work like this to where I can tell which cases you're talking about for which. I'll talk about it on the exam review, when we have that week before we take exam 3. But you do want to actually, box off your work separately, write them 2 different ways, use 2 different colors, I don't care. you would need this entire page of work to get full credit for this problem. I hope that answers your question. Okay, so over here, I typed it in the calculator, it gave me an error. So if you're sure that you typed everything in correctly and you're getting an error out of this, there's just no solution. You're actually just completely done with the problem. That means that there's no way you can make a triangle that has these particular measurements. It's kind of like you're saying, here is side A, here's angle A, I don't know, and then here's side B or something like that. So I don't know, this is a terrible drawing, but one of the sides is way too long, and there's no way to connect them to actually create a triangle without some overlap, flapping over. It's kind of like they're forcing you to draw the triangle like this. Hey, go ahead and connect these. And there's no way you can. This little side's too short. And again, that's a huge exaggeration, but that's what's happening here. Okay, last example. There we are. So the only possibility we haven't covered yet is what happens whenever you have ambiguous case and then the other case doesn't work out. So here's what it looks like. I'm going to start the problem with C and C. So you've got 20 over sine 40 equals 15 is A, so that gives me info for angle A. So cross multiply and divide. I've got 20 sine A equals 15 sine 40. Divide the 20 over. And then inverse sine. Okay, so I've got inverse sine. Hold on, let's scoot this over. No, stop. Can't use my pen to drag stuff over. So inverse sine of 15 sine 40 divided by 20. So I've got A to be 28.8 degrees. Okay. So I typed in inverse sine. Anytime you type in inverse sine at all, if you hit second sign on your calculator, you've got to check ambiguous case. So there's a chance A is 28.8, like my calculator is saying, but there's also a chance A is 151.2 degrees, the supplement of that. Right, I did that math right? Yeah, okay. So there is a real possibility that you've got two answers for A like we did earlier. So in the case, let's go ahead and do case one. I know what angle C is, that's fixed. If A is 28.8, that means angle B is what's left over. So B is going to be 100, let's see, 140, 111.2. I don't want to screw up something on the recording. Let's make sure we did it right. Hey, I can do math. All right, 111.2. So now I can find side B. So B over sine of 111.2. And you can set that equal to A over A or C over C. I'm going to use C over C because the problem told me it. So just multiply that sine of 111.2 over. And B is equal to, let's get out the old calculator, scoot it back over. So 20 divided by sine of 40 times sine of 111.2. 29.0. So there's case one completely done. Okay, I'm glad I didn't screw it up. Yeah, always double check to make sure you're in degree mode when you start these homeworks or this exam or anything. Check your mode every time you start a new thing. Now, if I hop over to case 2, angle A could potentially be 151.2. But remember, the three angles have to add to 180 degrees. But what happens if I try to do this? Subtract what I know. 40 and 151.2 give you 191.2. That's more than a triangle. There's no way you can get over 180 degrees in a triangle. I know C has to be 40. The problem told me it had to be. And A, I got by calculating the supplement. There's no way angle A can be this big and we can still fit inside of a triangle. So this is your proof that case B doesn't do any, or case number 2 doesn't do anything. You can't have angle A be this big. So when you check the ambiguous case and the other case ends up giving you angles that are way too big to fit within 180, there is your proof that you don't have a second triangle. So this problem, you only have one possible triangle, and these are the only solutions that you need to give me. I mean, you also have to show me the work for proving case 2 doesn't work, but here's what your page of work would look like for something that only has one triangle as a solution. And that's the law of sines. Ambiguous case obviously is going to be the one that bothers people the most. So just as a quick recap, quick Cliff Notes version of what we did here, TLDR, I guess. Here's the law of sines. You're going to use it a bunch. In order to begin any of these problems, you're going to need a pair, a matching letter pair. So side C and angle C, side A and angle A, whatever. Here we have B and B. Set that equal to one of the other ones that you know or that you don't know. And check for ambiguous case every time you type inverse sine. So that means if you look back here, this first example that we did, this is not ambiguous case because I never typed in inverse sine. If angle B is 40, angle C is 75, this problem didn't ask me for it, but angle A has to be the leftover supplement, right? Those add up to 115. You have to have 65 degrees for angle A. So there is no ambiguous case. The only time you have ambiguous case is if you type inverse sine into your calculator. And we talked about why that's the reason back here. Okay, so that is it for the lecture. Are there any questions live in chat over anything we covered today? Just one more dual credit thing. If you didn't tune in yesterday, just because yesterday was a high school lecture, but I talked about potential extra credit. This is for y'all as well. Oh, go ahead, Paneet. What's up? I'm just going to open the Google Classroom while you're typing. Oh, the high school pre-cal class. The next test is going to be over trig identities. So, yeah, you're the only one that's ever going to be dealing with this, but since you're in both classes. Test number 2 that you just took for dual credit, the verify the identity problems that you just did is going to be the whole test for the high school class. No, we're actually, we just covered the assignment and we're not going to have it on the test. Puneet. If we were testing over the cosecant, secant, tangent, cotangent graphs, we'd be doing it this week. And they told us to lighten the load, so that's one thing I decided to cut. Okay, so, notice how tomorrow, Wednesday, I said information on extra credit. It's going to be a Zoom presentation. So if you don't know what Zoom is, it's just a video conferencing website. The difference between something like Twitch and something like Zoom is that everybody has live access. There's no delay. Everyone has live access to everybody's webcam, everyone's computer screen, everyone's mic. So everyone can see and hear everybody. So we're going to do group presentations. For this first week, I'm just going to test run it so you can get potential extra credit on your average. I'll either do something like add it to a homework grade or something for dual credit. High school is a little easier because I know exactly where I can put the grades. But on Friday this week, I haven't determined the time yet, but on Friday this week we're all going to log into Zoom, so you need to have an account made by then. And I'm just going to check to make sure it works. And if you log in, I'll take a snapshot of the attendance and you get a little bit of extra credit. In a couple of weeks, or starting right after this, I'm going to give you a rubric or a template for a group presentation. You're going to have to find some teammates, and that'll be happening on Friday as well. And you can come up with a presentation. You're going to make a little PowerPoint or a Prezi or whatever you want to do, and you're going to present to us. It's going to be loosely math related, but yeah. That's what we're doing for extra credit. So I'll have more information on that tomorrow. Hopefully I'll try to have the rubric done by then too. I don't know if I will, but and then if you wanted, somebody requested all the blank presentations of everything we're going to do for chapter 6, so you had it right here. So I will post the annotated thing and post the YouTube video here as soon as it uploads. So any other questions? All right, I am going to go ahead and stop the recording, and we'll upload, and I will see y'all tomorrow or whenever I see you.